Hi guys, welcome back. So this problem here, I've moved classrooms, it's a little bit echoey, I do apologise. Now this question here, this is question 10 on page 322 of your textbook. So this is an example of a complex unfamiliar question. Now if I show you an example of a complex unfamiliar question, it is no longer complex unfamiliar. It now becomes a complex familiar question. So just consider that when you ask me to do these sorts of questions for you, and then consider what sort of things I might put on your exam. Because if I'm showing you these hard examples in class, then we have to put harder stuff on the exam. So I will show you this. Keep that in mind. Okay, so I've got this problem here, and the problem is if the polynomial is equal to this particular function, and the polynomial can also be expressed in this form, so pz equals z minus 1, z minus a cubed plus b, and then for z and a that are elements of c, so they're complex numbers, and b is an integer, determine the values of a and b. So that's the question from the textbook. So the first thing I'm going to do, I'm just going to rewrite this just a little bit because they factorize some stuff out, and I'm about to do long division, and I want to do long division with some stuff basically that hasn't been factorized. So I'm just going to write that like this so that we have, this is all like unfactorized now, is what I'm trying to say. I'm not speaking very well. I've been doing this for too long, I think. So all of these coefficients now are just going to be like all the stuff that's in the brackets here. And this is going to be the coefficient of our constant. And really I could write this like this as well if I wanted to. Okay, but we'll just leave that for now. All right, so what we're going to do is we are going to use this information here. Now, they're saying, effectively what they're saying is, because I've divided through by this value here, I'm going to be left with this cubic value plus a constant. So the first thing I'm going to do is I'm going to factorize out this z minus 1, and I'm going to do that using long division. So I've gone through the long division process a couple of times with you now, but this is getting kind of a bit nutso. Okay, so let me just finish writing this. Okay, so just as a review of this process, I'm going to divide, then I'm going to multiply, then I'm going to subtract, and I'm going to add if I need to, but generally I don't use this last one here when I'm dealing with polynomial functions. Okay, so to do this, we're going to look at this value here. Z goes into z to the power of 4 3 times, so z to the power of 3 times, and then I'm going to multiply this by my linear factor to get z to the power of 4 minus z to the power of 3. So I've done those two. Next, I'm going to subtract. Now, this is where it's going to get a little bit tricky because we're thinking about this in terms of the coefficients. Now, obviously, these two are going to cancel out because z to the power of 4 minus itself is going to be 0. Now this here, this is effectively, so if we were to look at this coefficient out the front here, we're minusing a minus, so it's effectively saying plus 1 z to the power of 3. So I'm going to add that to this coefficient here. I'll just show you what I'm doing in a little bit more long explanation. So if I had negative 1 minus 3i a plus a, then what I would do is I would add the coefficients out the front. So factorizing out this other a, I would get negative 1 minus 3i plus 1 like that. Okay, so that's where this next value is going to come from. So those two are going to cancel each other out, and I'm just going to be left with negative 3i z cubed. Okay, so it's a little confusing, but that's my subtraction part done. All right, so let's keep going now. So we're going to follow along here. So z fits into negative 3iz cubed, negative 3iz squared times. So this is exactly the same process. We're now just using complex numbers. And then now we've done our division, we're going to do our multiply. So this times by our linear factor is going to give me negative 3iz cubed plus 3iz squared. And then I'm going to subtract, so those two values are going to cancel, which is good, that's what we want. And then I'm going to have negative 3i plus 3, negative 3 plus 3i, so this comes from this coefficient here, minus 3i z squared. So that's going to cancel those two. So I'm just going to be left with negative 3z squared. All right, so same thing again. We've done our subtraction, repeat the cycle. Z fits into negative 3z squared, negative 3z times. Negative 3z times by my linear factor is going to give me negative 3z squared plus 3z. Then I'm going to do my subtraction. So negative 3z squared minus negative 3z squared is going to be 0. And then I'm going to take this information from up here, so the coefficient in front of my next factor. So that's going to be 7 plus I minus 3z. And so that's going to simplify to 4 plus I z. Okay, so that's my subtraction done now. We're going to repeat the cycle back again. Z fits into this, 4 plus I times. Z times by this is going to make 4 plus I Z plus, one sec. About that, just wanted to fix that up a little bit. I've just popped some brackets around here to make it a little bit easier to see. So we've found our factor. Now we've done the division part. We're going to do the multiplication part. So this is going to be this factor times by this. So that's going to give me 4 plus I Z minus 4 minus I. Then I'm going to subtract. So that's going to cancel each other out because 7 plus I minus 3 is the same as 4 plus I. Anything take away itself is going to be 0. And then I'm going to take that away from my constant. So my constant is here. Negative 4 minus I minus a negative is going to cancel each other out. So I have a remainder of 0. Okay, so a little bit of a long one. I'm going to summarize what my factor is and what the solution was here, and I'm going to do that on a fresh page. All right, so I divided through that original polynomial function by this to get this quotient in here. Now, the other piece of information, or the question I should say is asking me to do, is it wants me to express it in this form here, where I have z minus a cubed plus a constant b, like this. So we've got this first bit sorted because that's what the question gave us. We've now got this cubic function and we want to factorize this cubic function so it's in this particular form here. So what I actually want to show you first, this here is a perfect cube. Okay, so if I was to expand this out, I'm not actually going to do this the long way. I could actually use, binomial expansion or Pascal's triangle to do this, but I won't show you that today. But the answer I end up getting when I expand this would be z cubed minus 3z squared a plus 3, z, I keep writing x instead of z, 3za squared minus a cubed. Okay, so this is the perfect cube, or the perfect cube would look like. So if we go back now to our function, we've got z cubed minus 3i z squared minus 3z and plus 4 plus I. So this is not quite a perfect cube. So we could make this into a perfect cube. It's kind of like how with completing the square, we add in some values to complete the square. Well, we could add in some values to complete the cube. And then once we've completed the cube, so to speak, this value that's left on the outside here that we've added is going to be our value for b. So I kind of hope that that makes sense here. So I'm going to write, I might do this in a different color actually. If I write these as their equivalents for this value here, so I'm going to factorize out the z squared and just write the coefficients, then negative 3a is going to be equal to negative 3i. So that was our z squared coefficients. Then this one here, we've got positive 3a squared. Again, I factored out that z, factored out the z here, and that's going to be equal to negative 3. So those are the coefficients of z. And then this value here, negative a to the power of 3, well, it's not going to be equal to 4 plus I. We're going to have to add or subtract something to get this value here. So with this one, it's kind of easy to see then that A is going to be equal to I. So let's write that here. So A is equal to I. Now, does this work with our second value here? If I was to substitute in I squared is the same as -1. -1 times by 3 is going to make -3. So that's kind of confirmed to me that A is going to be equal to I. So for our last constant then, to complete this cube, we would have to do subtract I cubed. Now, I squared is the same as -1. -1 times by -I is going to make positive I. So we're going to have to add I in order to complete the cube. We don't have I, we've got 4 plus I. So what I'm going to do, I'm going to take the I from here because he's the one that I'm going to find useful. I'm going to leave this 4 outside the bracket just like we've done here. So we would write this as Z minus 1 times by, now we've worked out what our perfect cube values are going to be because luckily this one isn't too tricky. So this will be Z minus, what was it? I to the power of 3 minus, plus 4, close bracket. And that is our solution. What we should do is we should go back and check this because I don't think that the textbook has a solution for this. So I want to make sure this is right before I put this out in the wide world web. So we'll just leave this bit for now. So Z minus 1. Now, if we do this cubic function, Z minus I, we saw before that when we, oh my gosh, I'm cursed. I'm actually cursed. This other bell's going to go in 5 minutes. I'm going to probably have to pause so that we don't hear that second bell. Okay, so if I was to expand this using binomial expansion, I would get Z cubed minus 3IZ squared plus, that would be minus 3Z plus I. And then I've got this plus 4 on the end here. And so that is going to be the same. Z cubed minus 3. Yep. Oh, sorry. I don't know why I wrote I there. That should have been Z. Plus I. So that's now a complete cube, a perfect cube. And then we had this additional term 4 on the end. So these two are equivalent. Good. Okay, let's expand this out now using this last factor here. So this is going to be Z to the power of 4. Minus Z to the power of 3 minus 3IZ cubed plus 3IZ squared. I'll finish this off. Okay, I've just gone ahead and I've just finished expanding that. So now we can go through and we can collect our like terms, and we can do that by adding up those coefficients. So the coefficient of the first one is obviously just going to stay the same. Now, if I put a negative out the front here, I'm going to end up with 1 plus 3IZ cubed. If I put I'm going to put a positive out the front here, so that will end up with 3I minus 3Z squared. Now, if I put these in here, that's going to be 7 plus I, because when I add these two, I'm going to get 7 plus IZ minus 4 minus I. Let's go back. Where's my textbook answer? Because that has got the original solution. Scrolling back up. And yes, good. They are the same. We are incredible. The only difference is here I put the negative out the front here. They put the positive. Doesn't make a difference because the value is the same. So that's an example of a complex, now familiar question using completing a completing the cube type method and factorization of polynomials. Alrighty. Turns out not that complicated. It only gets a little crazy because of the long division. So thank you for bearing with me and being patient with me. I know there's been a few issues with technology and stuff and noise and construction and everything here at school. So I do appreciate you guys watching these videos. Thanks guys. I will see you next time. I'm going to start uploading some videos for the Unit 4 stuff that we're going to have to look at. All right guys, talk soon. See you later.